All right, so in the last video, we had some panel data where we had two groups, right? But that's often not going to be the case. Often we're going to have lots of different groups, observing them in lots of different years. So here we have an example data set where we're adding another group. So we have three different groups, and it's again a panel, right? We see Ramadi in both 2005 and 2006. So we're going to see how we can leverage the panel data-ness of this data set to improve an estimate that we might want to get for the effect of infrastructure spending on violence per se. And so notice here, I'm also making this a little bit more complicated by not just having a treatment variable that's a 1 or a 0, but some level of spending, right? Because often we'll have some kind of continuous treatment variable as well. So if I were to just graph this data and take a look at it, it might look something like this, right? And then if I were to just run a regression where I've got infrastructure funding as the independent variable and violence as the dependent variable, right? Essentially fitting this line, it would look something like this, right? We'd end up with an estimate that the effect of infrastructure funding is to actually increase violence. Now, importantly, you know, as you might be thinking about, what is that estimate missing? Well, it's missing the fact, it's not including anything about the fact that we're observing the same city at multiple points in time. So when we draw this line, if you're thinking about what's the counterfactual that we're constructing here, what are we using as our comparison, right? Because we can't actually see behind that door that we don't get to see, right? What we're using as our comparison for a city with high infrastructure funding is a city with low infrastructure funding, right? We're just making that simple comparison of a city in a given year with high infrastructure program funding to a city in a year with low infrastructure funding, right? We're not really using the panel aspect of this data. So let's think about what this looks like if we look at the cities individually, right? So here we have it color coded by the different cities. So here's one city, here's another city, and here's a third city. What fixed effects estimates do is, instead of just using any other observation as sort of to help us build the counterfactual, we're using an observation in the same city at a different point in time, right? If we have a city fixed effect, right? So by including a city fixed effect, instead of drawing just this line here, we're going to be drawing a line for each of these different cities, right? So it's sometimes called a within, you know, a within, in this case it would be a within city estimator, right? We're looking within a given city, what's the effect of infrastructure funding on violence? So comparing a city to itself in another year, right? So the key assumption is that we're going to have anything that's unobserved, that's different between all the cities. We could have some unobserved differences that we're not including in our regression, right? But we can only have them if those differences are constant over time, right? So we don't have to have all the different controls, so long as the things that we're missing that are important, right? Those omitted variables, as long as the effects of those are constant over time. So in other words, as long as, going back up here, as long as the different, you know, Tikrit and Mosul can be different, but they need to be different in the same way over time, if not, other than, you know, any effects of the infrastructure program, obviously, right? So unobserved differences between cities are constant over time. So another way economists sometimes talk about this is a fixed effects estimate will account for any time invariant differences between groups, right? If we've got this group fixed effect here. So think about what that means. Basically, what we're doing is something that's an extension of this common trends, right? The idea is that we've got these fixed differences over time between the cities, right? If you look back at our common trends sort of discussion, that's exactly what we had here, right? We were assuming that the difference between Ramadi and Mosul would be the same in 2005 as it would be in 2006, if not for this treatment, right? And we're doing the same thing down here with the fixed effects model. It's just sort of it's a little bit more complicated version of that same idea, right? But it can be really important to account for these differences between cities, as we see in this example, right? Because now our estimate of infrastructure funding is going to be negative when we sort of take the weighted average of these different slopes that we've drawn, right? That's going to be negative, right? Gives us a totally different conclusion about the causal effect of this infrastructure funding, right? Assuming our assumption still holds here, right? We're still building a counterfactual with an assumption. It's just a little bit weaker assumption than maybe we have in some of these previous examples that we've done. Right. Another way of thinking about this is it's basically like our high poverty example from a few videos ago, except instead of conditioning on high poverty versus low poverty, we're conditioning on a specific city. So we're looking, we're comparing this one city to itself, comparing this other city to itself, et cetera, right? Instead of just like a group like high poverty and low poverty, where we've got a bunch more groups that we're comparing to themselves. Okay, so fixed effects estimator, what is it doing? We'll just be a little bit more explicit about this, because I think it's helpful to kind of think through and to kind of understand when you see it, what people are kind of assuming when they're using this estimate. So basically the idea is we've got this assumption where unobserved differences between cities are constant over time. So in other words, if we have a very simple model here where we've got some outcome y, in this case we've been talking about violence, there's some difference between cities. So there's some difference between cities, and we've got some difference in funding in this case, with some coefficient, right? So there's some effect of funding. Then we have some unobserved time invariant city effect, right? So this is some constant associated with a given city I, and then we have our error term here that looks like this, right? So we're not observing any of this stuff here. That would be like all in our error term if we were to just run this regression with infrastructure funding here, right? So what are we doing with the fixed effects estimator? Well, what we're going to do is we're going to pull out the mean for all of these different variables, right? So we're pulling out the mean across the board, right? So we're going to pull out the mean of y. And when I write this, what I mean is, if we've got a bunch of different time periods where we observe city I, we're taking the mean of city I of this outcome for violence, or taking the mean violence over time for this city, right? Beta FIT, and we're going to be pulling out our mean of that variable, and then we're pulling out the mean of alpha I. Spoiler alert, it's a constant, right? It's constant for that city, so this is just going to cancel out, right? These guys are going to cancel. And then we've got whatever our error term is here. And we've got the mean pulled out of that, right? So basically what we're doing is we're just going to transform this data so that we can write something that looks like this, where we've just got a new definition of these variables. Where that sort of double dot thing there, this is just to represent, you know, that we've got this thing minus the mean. Minus the mean for that group, right? Okay, so we're just transforming the variables. And now notice what we've got here. We've got something where we don't have a bunch of this extra unobserved city effect in our error term, right? So because that we assumed that those effects of the cities were constant over time, by pulling out the mean of all these variables, right? We've gotten rid of this guy here, right? And so we can then estimate this just the way this regression with these new sort of transformed variables, just the way we would any other regression, and it's going to get us this estimate for beta that's going to have accounted for those time invariant differences between cities, right? And the way we do that in practice, if you were to do that in practice, we would just be putting a dummy for each group, or each city in this case, right? Right. Another way of saying is we're going to give each city its own intercept, right? Instead of just having one kind of alpha, we're going to have an alpha for each city. Okay, so just for fun, I thought we'd take a look at what this would look like in Stata if we were to actually kind of run this regression for using this data that we were just looking at, running it with fixed effects and without fixed effects. So let's start without fixed effects. So if I'm looking, I'm after the effect on YIT, which was violence, if you remember, looking at the effect of this funding variable on violence. We could do a simple regression. I'm not going to worry too much about standard errors here. Like for the moment, we're just thinking about you know, our coefficient estimates and getting some intuition. So let's run this very simple regression and see what we get. As we saw in that graph, we get some sort of positive coefficient here for this variable of the infrastructure funding, right? An extra $1 of infrastructure funding means we get a 0.3 increase in the number of violent incidents, or however we define that variable originally, right? So how are we going to implement our fixed effects regression? So I've got this variable for city here, which has a bunch of different variables. You know, it looks like it's text, but really this is just a label. You can see that if you look at this. If you look at what's sort of underlying each of these observations. So Mosul is 1, Ramadi is 2, Tikrit is 3, right? And when I've got things in that sort of format, there's a very easy way that Stata lets you do this, right? Basically, I can run a regression where I'm doing the same thing, but now I can put in something that's I.city. And what that does is for each of these cities, it's gonna put in a indicator variable for that city, right? So there's gonna be an indicator for Mosul, there's gonna be an indicator for Tikrit, right? If you think back to metrics 1, right, there's not gonna be an indicator for every city, right? There's always gonna be one dropped out because they're gonna be estimated in relation to some baseline, right? And so there's always going to be some base city that, you know, the other cities are going to be estimated in relation to, right? And that's going to be sort of where this constant comes from, right? So we've got estimates for the time invariant differences between Ramadi and Mosul, between Tikrit and Mosul, and then we've got our fixed effects estimate of the effect of infrastructure on violence, right? And here we see it's actually quite negative, right? A dollar more of infrastructure means 1.6 fewer violent incidents in a city, right? Assuming that we don't have anything weird where these different cities are kind of trending in different ways, right? They can't be trending in different directions, because that would mean that those differences between cities aren't going to be constant over time, right? They always have to be trending kind of together, just in the same way that that they did with our difference in difference strategy. Okay, so let's talk about generalized difference in difference then, and how does it expand on our standard diff and diff, right? So our standard diff and diff, we had, you know, two groups, pre and post, treatment and control, right? And we had, if you remember, we've got an indicator for, you know, are you in one of those two groups? We've got an indicator, are you in the, you know, the post period? And then we've got that treatment variable there that's varying across within groups over time, right? Within at least one of the groups over time. So to generalize this, we're going to, instead of just having one group, a treatment group and a control group, we're going to have a few groups, right? So in our example, right, instead of having just a treatment group, we're going to have each of these cities. We're going to have an indicator for each of these cities, right? Excluding one, right? Because we're always going to exclude one base case, because these are estimated in relation to the base case. So we've got multiple groups now, and we're also going to have, or we could also have, you know, maybe we don't. In this case, I think we didn't, but in many cases, we're going to have multiple years. So in this, I'm going to pretend we had like 3 years here. We're going to have two fixed effects, or two indicator variables, one for each of those years, right? And then we're going to have our variable for, are you treated in a given year, right? And so this guy's varying within these cities over time, right? Because we need something to vary within the city over time, because that's where we're getting our estimate from, right? That's where we're getting our comparison that we're gonna make. We're looking within a city over time, right? So what are these guys doing? These guys are saying, you know, we're pulling out what's happening on Ramadi, in Ramadi on average, what's happening with Tikrit on average, right? So we're accounting for these average differences between the cities. We're also accounting for average differences between the years, right? We're pulling out, you know, what's happening on average in 2005 across all these cities, right? It's a bit like how we had this post period, right? That was getting at, you know, what's happening differently in the post period versus the pre period. This is sort of on average, you know, in both periods, how different are the treatment group from the control group, right? And this was our treatment here. This is our treatment here, right? And so this is going to be our generalized difference in difference estimate. There's a few other ways we could write this, right? If we had a bunch more cities and years, we might write it like this, right? And you can sort of think about what does this piece mean? We're just adding up for each city from 1 to n. the indicator of is this city I, is this row in the data set that we're looking at, is city J the city in that row, right? And that's going to give us this beta J, right? So same idea that I was just talking about here. It's just we're sort of making it a little fancier with the summation. Often you don't see that in actual journal articles. You'll see something that looks a little bit simpler like this, where they'll just write one Greek letter with an index to it to represent this whole term here. So this would say we're going to have fixed effects for each city, right? And the way it would usually be termed is we're going to have city fixed effects and we're going to have year fixed effects in this regression. So that's how you usually see it in a journal article.